Alright class, now we're going to take a look at negative exponents and the rules that go with it. We've got negative exponents and then we'll go into the quotient rule, which is very similar to negative exponents. So to begin, we've got this property in the top right hand corner where if we have a negative exponent, a to the negative n, what happens is you bring it down to the bottom. So I have a to the negative n. What's happening is really this is over a 1. And we take whatever this is, bring it down to the bottom, and make it positive. So it just flips it over on 1 over a to the negative n, or positive n, I'm sorry. So what's happening is I call negative exponents, these are frowns. So these are sad faces. And then what happens is you take them and bring them to the bottom. You need to take that frown and turn it upside down so that this is a happy, positive exponent. So you take your frown, your negative exponent, and turn it upside down. And now this also works if I have something on the bottom. If I had 1 over b to the negative x, this is a frown on the bottom. So I take my frown and flip it upside down. So I take this whole fraction and flip it over and put the 1 on the bottom, the b to the positive x on top. So we take our negative exponent, move it up to the top. That's our frown. We turn it upside down. Okay, so let's take a look at all these problems that have frowns in them and try to turn them all upside down. So we've got 2 to the negative third. That's a frown. I need to put it over, imagine it being over a 1, and flip it over so that it's 1 over 2 to the third power. This has been a frown. I flipped it upside down. Now you might need to further simplify this because it's not, some of them are, if it's like 2 to the third, we can simplify that. If they're huge, then that's another thing. But I've got 1 over 2 to the third, that's just 8. So the answer is 1 over 8. Okay, so if it's small, I probably need to simplify it. So let's take a look at the next one. Now notice the 5 and the z are being raised to the negative third power. So they both have the frown, so they both need to be flipped upside down. So it turns into 1 over 5z to the positive third power. Now, notice I put the parentheses back on there because they are both being raised to the third power, not just the z. So I actually need to distribute the 3 and make this 1 over 5 to the third, z to the third. And that can further simplify to 1 over 25. Sorry, 125. Z to the third. Okay. Now the 6 to the negative 1. This just turns into 1 over 6. Nothing special going on there. It's just that it is the negative 1 power. And notice I didn't put the 1 back there. You could. There's really a 1 there, but you don't need to write it. It's just 6 to the first power. The first power is understood. So now check out this last problem and try to notice how it's different between the second problem and the last problem. They're very similar looking, but notice there's no parentheses, and that means that the negative 3 is only on the z, not on the 5. So this is where it gets a little tricky. Let me write it up here a little bigger. 5z to the negative third. Now there's still a fraction bar. It's really over 1. The 5 does not flip. It stays. It already actually has a positive 1 happy exponent. This one's sad, so that's the one that I need to flip over, just the z. It needs to go down. So I'm going to write z to the positive third on the bottom. And so my answer is going to be 5, which stays on top because it's already got a positive exponent, over z to the third power. And that is my final answer for that problem. Now in this next problem you can see that we have a very negative m. Now it goes on, the negative goes on the outside. It can be on the top or the bottom of the fraction. The negative 3 of course is the power that causes this to flip. So what we're looking at is negative m to the negative third over 1. The negative can stay on the top or the bottom. Usually I just leave it on the top or on the outside. So negative 1, because there's really a 1 in front of there. The m goes down to the bottom, so it's m to the positive third power. Now you could have written it like this, or you could write negative 1 over m to the third, or the negative could actually go on the bottom, but I usually put it out in front like that. Now this one is a little bit different because the negative sign is in the parentheses. It doesn't mean anything at the beginning of the problem, but once I move it to the bottom, so this is going to turn into over 1, so it's going to turn into 1 over negative m to the second power. Now the reason why it's important that the negative sign is in the parentheses is because if you take a negative m and square it, this is negative m times negative m is what that really means. And negative times negative is positive, so it's actually positive m squared. So it's a little bit of a tricky finish there. The answer is 1 over positive m squared. The negative sign got squared. Whenever you take a negative, so a negative to a even power, the answer will always be a positive. Okay, so that's something that you want to kind of hang on to. If ever you have a negative number to an even power, the answer will always be positive. So that's what's going on in the second problem there. So now let's look at a little bit more arithmetic after we actually flip. So we've got 5 to the negative 1 and minus 2 to the negative 1. So what they want us to do is flip it. So I got 1 over 5, and then I subtract 1 over 2. So I have to do a little bit of power stuff, power rules, and then it turns into arithmetic after that. So I actually have to subtract my 1/5 minus 1/2. And I know many of us aren't very happy that I have to deal with fractions now, but I've got to remember back to my fraction rules, which is I need common denominators. So I multiply this one by a 2, top and bottom, and I multiply the right one by a 5, top and bottom. And that's going to give me 2/10 minus 5/10. And so my answer is a negative 3/10. So yes, you will actually have to do a little bit of arithmetic, but if you have a nice calculator, it might do it for you. So let's do another one. Very similar. So I need to flip them first, so it makes it 1/3 plus 1/4, and then I continue and I multiply, making common denominators. This one by 4, this one by 3, and that turns into 4/12 plus 3/12, and then I add those to make 7/12. Because you can't reduce, that'll be your final answer for this particular problem. And now we're going to take a look at some negative exponents that are on the bottom. Again, these are still frowns, okay, so we need to turn them upside down by moving them to the top. So it's going to turn into 2 to the positive third, so now it's a happy exponent. And then if I can simplify it and realize it's just 2 to the times 2 times 2, which is 2 to the third, and that gives me 8. Now this one, they both have frowns, so they both need to flip. So this one's a frown on top, this one's a frown on bottom, so they both need to flip over, and that's going to turn into 3 to the second power over 2 to the second power. And then I go ahead and again further simplify, and this is going to give me 9 over 4. And that'll be my final answer there. Now this moves us into the quotient rule for exponents. Now the quotient rule for exponents is that if I'm dividing the same base, now notice on the last problems they weren't the same base, so there wasn't anything to do, but they're now the same base, and what you do when we were doing a product rule, so if it was 3 times 3, so 3 to the 7th times 3 to the 2nd, I was adding them to get 3 to the 7 plus 2. Now what I'm doing, because it's the quotient rule, this is really 3 to the 7th minus 2, because it's division. So 3 to the 7th divided by 3 to the 2nd turns into subtraction. So where the product rule turned into addition, the division, the quotient, turns into subtraction. Okay, so what that means is that all I have to do for this first problem is subtract them, and that turns into 3 to the 7 minus 2, which is 5. Now another way of looking at this that it's even cleaner than actually remembering the rule is I like to cancel exponents. So if I've got 2 3's on the bottom and I've got 7 on the top, I want to take these 2 and cancel them out with 2 of those, and that turns into 5. And you're still subtracting, but it kind of cancels, so it's a little more visual where you're canceling things on the top and the bottom, and that way we don't write out the subtraction. So you can do it either way, but it makes a little more sense when I get to this problem in particular, because what happens is if I'm using the rule that I was showing you, I turn into k to the 7 minus 12, and we end up with a negative exponent, so k to the negative 5th, and then you have to remember that I don't leave this on top, I actually flip it down and make it 1 over k to the 5th. And it's a lot easier if you're just looking at the beginning of the problem to go ahead and just cancel. So I would just say, oh, there's 7 k's on top, cancel 7 of those with 7 of these, and there's 5 left on the bottom, so that means I still have 1 over k to the 5th, and I didn't have to do any extra flipping at the end. So that's the way that I prefer to do it. You can choose which one you want, but I'm going to continue doing the canceling way. So on this one, I've got 2 on the bottom. I'm going to cancel them out with 2 on the top, and that leaves me with 4. So this one just gives me p to the 4th power on this final problem here. And then on these problems, you continue to do the canceling way, but you have to make sure before you cancel, notice all the problems on this last slide, they all had positive exponents at the beginning. These were all positive. Now notice on this next slide, these ones have negative exponents also. You can't do the canceling until you have positive exponents. So what I need to do is take this -3 and move it up to the top. So now it's going to be 2 to the 7th times 2 to the 3rd. So this actually isn't a quotient problem at all. I'm actually going to do a power rule and add them. So this is going to turn into 2 to the 10th. So there was no subtraction or canceling. So a similar thing happens here. I'm going to move this down to the bottom because it's a negative exponent, and I get 1 over 8 to the 5th times 8 to the 2nd, and that's going to give me 1 over 8 to the 7th. So there wasn't, again, any canceling. I actually have to move first. So now look at this last problem. This one, they're both negative, so I need to flip both of them. So it's going to give me z to the 8th, positive, over z to the 5th. And now, because there's some on the top and on the bottom, I'm going to cancel the 5 on the bottom with 5 of the ones on top, and I'm left over with a 3. So the answer is z to the 3rd. So that is using the quotient rule. Now, I put this last problem on here just to remind you that just because there's a variable on top and there's one with the exponent on the bottom, you can't cancel them unless they're the same base. So that's what I have for you for the quotient and other exponent rules here. And by other, I meant negative exponent rules.